And here we have an objective of you will determine what makes a sequence converge. So we got to figure out, obviously, what makes a sequence converge. So in our class, we have talked about the convergence of improper integrals, and basically that was if I pretend the integral is normal and then evaluate and introduce a limit, and then I evaluate the limit, and I get a number for that limit, then the integral converges. Now for a sequence, we're not adding anything up. For a sequence to converge, that means we go to some number. So the limit of that sequence, as I'll write it as n goes to infinity, or I could write it as a k. So the limit of those individual terms has to be some number. Often they call it L. L is some real number. So if we approach some number, not infinity because that's not a number, could be 0, then the sequence will converge. If we do not, then obviously we do not. Now we'll look at some examples on the next page. So we want to look at these and we want to say whether the sequence is monotonic, eventually monotonic, bounded above or below, and whether we're going to converge. So let's take a look at what we got. Make these a little bigger. So monotonic are eventually monotonic. So what that means is, are we going to kind of get continually increase or continually decrease, or are we going to have something else going on? If we think about this one, that's going to go, if k is 1, it'll be 2. And then if k is 2, it'll be like 1.5, 1 1/3, 1 1/4. So yes, that's going to be monotonic. And that's going to be decreasing, so monotonically decreasing. And then the limit, as k goes to infinity, that's a 1, not an infinity. As k goes to infinity, of my 1 plus 1 over k is equal to 1. So that one will converge. And we are bounded below for that one. We kind of are bounded above since we start at 2. So I guess I would say we're bounded overall. The next one, we got cosine pi, k pi. So let's think. If k is 1, cosine of pi is -1. If k is 2, cosine of 2 pi is 1. If k is 3, cosine of 3 pi is -1. So this is just going to bounce. On the previous page, I was going to mention something like this, where we do not converge. So this is not monotonically increasing or decreasing. We are bounded, but we do not have a limit, so we do not converge. So this one diverges. Okay, we are bounded because we're stuck between -1 and 1. In fact, we're stuck at -1 and 1. K to the 1/10. So if I raise k, or if I take k and I put bigger and bigger and bigger numbers in, and I raise it to the 1/10, that's like the 10th root. But that's just going to keep getting bigger, and I pretend it's a function, not discrete points. That's going to keep getting bigger and bigger and bigger. So I could say we're bounded below if we plug in like 0 for k, or 1 for k. We're bounded below. We are monotonically increasing because this function keeps going up, but we do not have a limit, so this one also diverges. 1/5 to the k. So 1/5 to the k, if we plug in 1 or 0, it doesn't matter which one we start with, we have 1/5 and then 1/25, and then 1/125, etc. So that's going to be monotonically decreasing. We're going to be bounded, I guess I would go above and below. Above by whatever number I start with. Below by 0. And we are always decreasing. So monotonically decreasing, said that. And we're bounded below. Our limit is 0. We're bounded above by whatever we start at. So if we start at k equals 0, it's 1. If we start at k equals 1, it's 1/5. Whatever our k value, wherever our k value starts, I should say. All right, now let's see. N squared minus 2, n squared plus 2n plus 2. So the first thing I'm going to look at is the limit, because that's what this is begging me to do. as n goes to infinity, the limit of an. So as n goes to infinity, the 2 on the top and the 2n plus 2 on the bottom don't matter that much. So essentially we have n squared over n squared. And as n goes to infinity, that's going to be 1. You could also go ahead, if you wanted to make a slightly different argument, divide everyone by n squared. N squared, n squared, n squared. Then you should be able to see relatively easily that those pieces will go to 0 as n goes to infinity, and then obviously we're left with the number 1 out there. So the sequence does converge to 1. And if we were to look at some values here, I bet we would be bounded above and below. And if we, so n squared minus 2 is going to be bigger as n gets bigger, and then n squared plus 2n plus 2 is also going to be bigger. So we're going to be growing over time because we have to reach that 1. So we'll get closer and closer and closer to 1 as we go. So that's going to be, I'm hesitating because it kind of depends on exactly what k value you start out, because obviously, or n value. If you start at 1, then obviously that's a negative number. But I think we're still going to be increasing that whole time. So we'll be monotonically increasing. If you're confused, especially by that last one, look at the graph. So pretend those are x's. Look at the graph, and you can kind of convince yourself of exactly what's going on.